My name is Joshit and welcome to Gradeup, India's largest live learning platform. In this session, I'm going to discuss the questions related to your open channel flow, and basically from today, we are beginning the open channel flow practice questions. So quickly, please let me know everyone if I am audible and visible properly to each one of you. Everybody, kindly please let me know if I'm audible and visible, and then we are going to begin today's session. And first of all, I'll introduce myself to those who are watching me for the first time, and kindly like the video as soon as you join the session, share this video with any one friend of yours, and also subscribe the channel if you are new to the session. Okay, so hi Aman, good evening dost, how are you? Everything is fine, everything is perfect, best. So I'll just quickly introduce myself to those students who are watching me for the first time. Guys, my name is Joshit Singh and I have 3 years of teaching experience. I'm MTech from IIT Roorkee. My specialization of MTech is in hydraulic engineering. GATE multiple times qualified, and area of expertise are highway engineering, transportation, basically you can say, fluid mechanics, irrigation and environmental engineering. So I have a lot of questions for you here. So we'll just begin in just few seconds. Till then, kindly please let me know guys that how are you doing? Everything is fine? Sab set hai? Koi dikkat? Anybody? Everything is going fine? How many of you have attended all the sessions which we have done on this fluid mechanics? Is there anyone who have done each and every topic? All government. Hi sir. कैसे हैं आप? What is your name? आपका नाम क्या है दोस्त? Okay, and there is one more information which I have to give you, and that information is something. It is something related to something which you are waiting from a very long time. So let me tell you guys that yes, the midnight series is here, and from 20th November we are beginning the traffic engineering midnight series, and this is going to be happening on the Gradeup Civil Champion YouTube channel. And the mode of conversation or the mode of communication on this particular in this series will be in Hindi only, right? My explanation will be in Hindi, technical terms will be in English only. Okay, Rashid, kaise aap? Perfect. So shall we begin the session, guys? Full power ready. If you are ready, can I have a heart sign in the comment box with full power? And then let's begin the topic. Let's begin the questions. I have good questions from this particular topic, and you'll be having sufficient amount of time to answer the questions. All right, and let's begin this without any further delay. So this is the first question, which says what is the normal depth in a wide rectangular channel carrying 0.5 meter cube per second discharge at a bed slope of this much, and Manning's coefficient is also given as 0.01. Everybody quickly answer denge. Okay, so we have this discharge given as not 0.5 meter cube per second but meter square per second, right? So that is small q basically, right? Okay, answer everyone quickly. Answer everybody with full power. I want answer. Try kijiye. Yes. I'll be explaining in this channel, in this YouTube channel. I will only speak in English, but on Gradeup Civil Champion YouTube channel, I will be using Hindi only, right? But here I'll be using only English. So don't worry. So yes, we have this B, you can say the discharge is given as 0.5 meter square per second. So basically we have discharge per unit width, that is small q. So what is the normal depth in a wide rectangular channel? So whenever you have to find out the normal depth, guys, the best way of finding out is using the Manning's equation. So now let's put the Manning's equation and let's see what is the answer that we are getting. As per the Manning's equation, we know the velocity of flow is how much? 1 by n r raised to the power 2 by 3 under root s, where n is the Manning's coefficient, which is given in the question as 0.01. R is wetted area by wetted parameter ratio. S is the bed slope. Okay. So now I want discharge, right? So I'll be multiplying area both the sides. So if I'll multiply here, so area into average velocity is discharge, and here it will be half area r raised to the power 2 by 3 under root s. Guys, they are saying that it is a wide rectangular channel. What is wide rectangular channel property? Basically, they are saying that the B value, the bed width, will be very greater than the depth of the flow. So we can say the wetted parameter is area by parameter. So sorry, the hydraulic radius is wetted area by wetted parameter. Wetted area will be how much? B into Y only. Wetted parameter will be how much? B plus 2y only. But as I have told you, B is very big, or you can say larger or greater than y. I can say this B plus 2y is almost equal to B only. It is almost equal to B only, right? So my hydraulic radius will be By upon B, and that would be y only, right? That would be y only. So 1 by n, not 2 here, 1 by n, area will be B into y 2 by 3 under root s. Guys, what is y into y raised to the power 2 by 3? That would be 2 by 3 plus 1, how much? 5 by 3, right? So q by b 1 by n y की power 5 by 3 under root s. This value I know, this value I know, this value n is given, y find out करना है, and s is the bed slope given in the question. Put all the values in the equation and please let me know what is the answer that you all are getting. Everybody quickly please tell me what is the answer that you are getting. So y raised to the power 5 by 3 should be equals to q into n divided by under root s, correct? So this should be y raised to the power 5 by 3, small q is 0.5, n is 0.01 divided by 0004, that too in under root. So when I try to find this out, everybody let's see who will give me the first answer. 0.5 into 0.01 divided by under root 0.0004, and this gives us the value as 1 by 4, and that too you have to do the raised to the power 3 by 5. 3 by 5 you have to do, and this would be 0.4352. This would be 0.43 meter, and which is option C. Very good Vatsal, very good Aman, great guys, amazing response, बहुत बढ़िया दोस्त. चलिए, if anyone got any doubt in this particular question, kindly ask, otherwise I will move to the next question. Anybody got any doubt? Very good Nivedita. Anybody got any doubt? Please kindly let me know. दिवाली के बाद मैं काफी स्टडी करूंगा सर. That's good. What happened? Set है. Next question. A rectangular channel is having cross-sectional area and wetted parameter as 3 meter square and 5 meter respectively. The bed slope is also given. The average shear stress on the channel boundary will be how much? So they are asking you about the channel boundary. How much that would be? Kindly please let me know, guys. On the channel boundary, guys, tau naught value will be how much? It will be gamma r s naught. Gamma unit, you know what is gamma, rho g, right? R, you know, wetted area by wetted parameter ka ratio. S naught is the bed slope. You have everything given in the question. All you have to do is put the values and get the answer. Let's see again who will give me the first answer. Let's see who is going to give me the first answer. So the tau naught value would be gamma rho g. We have water. So density of water is 1000 here. G is 9.81. R is wetted area by wetted parameter. So wetted area, is it given to us? Yes, it is. It's 3 and wetted parameter is 5 into S naught 0.004. How much? How much? It was a very easy question. How much? It should be 23.54 Pascal. Are you getting the same answer? Everybody? Everybody? So easy question, right? No problem, I suppose, in this, right? Okay, next question. Alright, so for a hydraulically most efficient symmetric trapezoidal section of an open channel flow or open channel, which one of the following is a false characterization? Out of all these four, which one is wrong? You have to tell which one is wrong, right? So please tell me quickly, everybody. Wetted parameter is minimum, or do one thing, now let's make it instead of MCQ, now it is a MSQ. So more than one option are correct. So quickly please respond. Out of these four, which option are correct? It is a MSQ question, everybody. Now it is an MSQ question. It is a MSQ question. Wetted parameter is minimum for given area of flow section. I want the flow characterization. I want the characterization for most efficient symmetric trapezoidal section, right? Hydraulic radius is half the flow depth. Width at top of the liquid is twice the hydraulic depth. Discharge is maximum for the given area of the flow, bed slope and roughness. Everybody will respond to this question because it is a very good question, and in one question you will understand three things, and that's the best thing about this question. Everybody give your best and kindly let me know what should be the correct answer. Before that, let me tell you what is the four criteria that we look for most efficient, or you can say most efficient or economical channel section, right? See, the channel section where you have minimum parameter, when the wetted parameter will be minimum, you can say it will be a economical and efficient channel section. Why economical? Because if wetted parameter will be lesser, I have to provide lesser lining. It will reduce the cost of the lining. It will become economical. If the wetted parameter will be less water will be there in contact with the solid boundary. Less water will be there in contact with the solid boundary means less shear stress will be developed. Less shear stress will be developed means less losses will be there. Efficient channel section. So that is why a minimum wetted parameter ensures that you have an economical and efficient channel section. This is clear or not, everybody? This is clear or not, everybody? Right? Why it is efficient and why it is economical. Now, the four criteria which I was talking about for a most economical trapezoidal channel section is, first criteria is the top width. Half of the top width should be equal to length of one side slope. One side slope. Okay, what does that mean? So suppose if this is the trapezoid, so this top width, half of the top width should be equal to this length. Okay, should be equal to this length, and it should be symmetrical also. Second is this angle here should be 60 degree. Third criteria is that the hydraulic radius should be y by 2. Hydraulic radius was what? Wetted area by wetted parameter ratio. And the last one is the bed width should be equals to 2y by root 3, where y is the depth of flow. So these four criteria, if they are ensured, then you are going to get the most economical and efficient channel section. So now the correct answer will be how much? Everybody quickly respond. Yeah, so wetted parameter is minimum for given, this is correct. Hydraulic radius is half the flow depth, it is also correct. Width of top of the liquid is twice the hydraulic depth. No, it is not like that. Discharge is maximum for a given area. Obviously, since it is efficient, losses are less, so discharge will be increased. So am I clear with this? Option A, B and D are correct. A, B and D are correct. Anybody got any small doubt? Then also please ask. Is it clear? Very much clear? Perfect. Next question. For a hydraulically efficient rectangular section, the ratio of width to the normal depth is. So again, I'm telling you guys, for rectangular, the only one criteria that you need to understand for becoming a normal rectangular section to become one economic or efficient or you can say efficient rectangular channel section. The only one criteria which should be there is when your bed width will be equal to twice of the depth of flow. That's it. For rectangular channel section, if you satisfy this particular thing, that your bed width, if I try to draw here, suppose if this is my rectangular channel section, this is the flow depth. So guys, this B value, it should be equal to 2 times of the depth of the flow. If you will make sure this one thing, you are going to get the most economical, or you can say most efficient channel section. Right? So the correct answer should be how much? The correct answer should be how much? B upon Y should be equal to 2. So C is the correct answer. Got this? Everybody got this? Yes. Very good, Jayesh. Very good, Nivedita, Aman and Vatsal. Very good, guys. Next question. A hydraulically efficient trapezoidal section of open channel flow carries water at a optimal depth of 0.6 meter. Chezy's coefficient is 75 and bed slope is given as 1 in 250. What is the discharge through the channel? Sir, answer please. Very good, Kenneth. Correct answer. Kindly please let me know the answer for this particular question now. A hydraulically efficient trapezoidal section of open channel flow carries water at the optimal depth of 0.6 meter. Chezy's coefficient is 75 and bed slope is given as 1 in 250. What is the discharge through the channel? That's it. This is what you have to tell. If you don't know, let me tell you guys, the Chezy's equation, with the help of Chezy's equation, the velocity, the average velocity can be found out by this formula. C under root RS, where C is Chezy's constant, R is hydraulic radius, which is nothing but the ratio of wetted area by wetted parameter, and S is the bed slope. And if I want the discharge, just multiply area both the sides. So area into average velocity is discharge, right? And here also CA under root RS. So this would be discharge is equals to CA under root RS. Put all the values and get the answer, everybody. And remember, in case of a trapezoidal channel section, in case of efficient, they have said efficient, right? They have said efficient. So for efficient, let me tell you few things, okay? What is the geometrical properties of an efficient section? That you need to understand, okay? Let me tell you all the geometric parameters. So first of all, the top width. The top width for most economical or efficient trapezoidal section should be 4y by root 3, where y is the depth of flow. Area should be root 3 y square. How I am getting these value? I have told you 4 criteria. On the basis of those 4 criteria, you can get all the geometric parameter. I am telling you directly, right? Wetted parameter will be 2 root 3 into y. Hydraulic radius, we have seen it is one of the criteria also, y by 2. Characteristic length is area by top width. So area we have just got as root 3 y square, and top width we have also got as 4y by root 3. So eventually this will give us the value as 3y by 4. So I know for efficient trapezoidal section, the area will be how much? Root 3 y square. So first of all, get me the value of area. Everybody, let's see how much is the value of area that you are getting. Everybody, let's see how much is the value of area that you are getting. Very good, Vatsal, you have got the final answer also. That's perfectly great. Amazing. So, okay, so the area will be how much? It should be root 3 y square. Cool. So, root 3, and what is the value of depth? It is 0.6. So, 0.6 square. So, from here, the area should be how much? Root 3 into 0.6 square. And guys, this should be 0.624 meter. This should be 0.624 meter, right? This is meter square. This is the area, right? This is the area. What else? R is given to me. R is y by 2. So no problem. R would be how much? Y by 2 is 0.3 meter. So putting all the values, C is 75 into area is 0.624 under root 0.3 into how much is the S value? 1 by 250. Let's put all the values and let's see what is the answer that we are getting. 75 into 0.624 into under root 0.3 into 1 by 250. Correct? Yep. So this should be 1.62, 1.62, it's fine, only this much, meter cube per second. So that is option B. How many of you have got the same answer and how many of you have doubt? Kindly please let me know if you have got any doubt related to anything that I have discussed here. But if everything is crystal clear, kindly please send me a heart sign so that I can know that we are having an mutual understanding. Everybody, heart signs, full power. If you are enjoying and if you are getting that what I have done here on the board. Yes, very good, Vatsal, very good. Suri, just see, आपने कहीं पे एक कोई छोटा मोटा mistake किया होगा. Just check where is the mistake, okay? Very good, Ross. Very good, Aman, Nivedita, and Jayesh. Great, guys. Correct answer. Amazing. Now, we'll move to the next question. Alright, we'll move to the next question and let's see what is the answer. And let's see if we can solve that question also. Alrighty then, next question. A hydraulically efficient trapezoidal channel section has a uniform flow depth of 2 meter. Always remember, whenever the flow is uniform, at that time, the depth of the flow will be known as the normal depth. Okay? Just calculation mistake. No problem, no problem. Just see whatever the mistakes you are making today. It's fine. You can make all the mistakes, right? All the mistakes. But remember those mistakes and do not make them again. Okay, this is not your exam. This is where we practice. In practice, you learn, you fall sometimes, you get injuries, right? It's fine. It's fine. So, jitna galti karna karo, whatever mistake you want to make, just make it and don't repeat them in the examination. Cool. This question, a hydraulically efficient trapezoidal channel section has a uniform flow depth this much. The bed width is given as, okay, the bed width we have to find out. Okay, perfect. Bed width we have to find out. Let me draw the diagram. And again, they have said efficient trapezoidal channel section. We have 4 criteria. Let's see if we can use any one of them, right? That was a hint actually. This is my trapezoidal channel section. Suppose this is the bed width. Okay. Okay. Very fast, Vatsal. Great. Correct answer. This is the bed slope. The flow depth. How much is that? 2 meter. Cool. And this is B value. All we have to find out is the value of B only, right? All that we have to find out is the value of B. Everybody, please solve and let me know the answer. You know something about the hydraulically efficient trapezoidal channel, which will be used in this particular question to find out the value of B. Just think about it. Just look at the geometry of the drawing and try to find out what should be the answer. Jayesh, very good. Everyone else, please try. Suri, try. Aman, try. Ross, try. Come on, answer. Rashid, Nivedita, Jyoti. Great, Suri, correct answer. Others also, Nivedita, great. Who is left? Rashid is left, Jyoti is left, Aman is left, Ross is left. Come on guys, answer. You can get this. Trust me. You have all the important, all the necessary data with you. Very good, Aman. No problem. I'll be telling you what you have to do here. So guys, here, do you remember I have told you this angle, theta, it should be 60 degree for the hydraulically efficient trapezoidal channel section. Did I remember I have told you this thing. Okay, things are very easy now, right? You can clearly see that with the geometry B sine 60 degree will be equal to D, or in my terminology it's Y. So I can say guys that B will be equal to Y upon sine 60 degree. Very good, Ross. So this should be how much? This should be 2.309, or you can say 2.31 meter. Everyone got the correct answer, and that's when I should feel proud. Great. Amazing. Bahut hi sahi. Alright. And the last question is from your triangular channel section. Okay. So guys, for triangular efficient channel section, let me tell you that this angle here, it should be 45 degree. Okay. This, or you can say this 1 in M slope, right? This slope 1 in M. Here M value should be equal to 1. Anyway, both the things are same. Either you say 45 degree, this angle is 45 degree. M is what? M is 10 theta and theta is 45. 10 45 is 1 only. So the same thing I'm talking about. But yeah, that's it. If you have this value theta equals to 45 degree, that's it. This is what all you need to get. So now please find this value. The value of Y you have to find out. Very good, Rohit. Correct answer. Answer, everybody. Come on. You can get the answer, guys. You can get the answer. Right? See, again, you need to get the value of what? You need to get the value of Y. What do you have? You have discharge, right? So let's find out with the, and you have the Manning's coefficient. So I'll be using the Manning's equation. That is quite obvious now, right? If you have Chezy's constant, you go for the Chezy's equation. If you have Manning's constant, you go for the Manning's equation. So Manning's equation goes something like this. Average velocity is equals to 1 upon N. N is the Manning's coefficient. R, which is the hydraulic radius, raised to the power 2 by 3, under root S. S is the bed slope. If I want to get the discharge, just multiply area both the sides, LHS and RHS. Area into average velocity, discharge. And here it would be half into area R raised to the power 2 by 3 under root S. Now guys, let's see what else we have to get here. What is the area for any efficient triangular channel section? What would be the area? This is the first question, right? So I have just told you guys that M value will be, the slope will be 1 only. This here 1 in M, M is 1 only. So guys, this will be how much? This will be my. Cool. This will be my and this will be my only. So top width is 2 my. So let's find out with the help, and m value is 1 only, right? So area should be how much? Half base into height. What is the base here? Base is 2 my into y, the depth. So 2 cancel out. M I know is 1 for most efficient channel section. Area will be equal to y square. Do I have the value of y? No, I don't. I have to find out. No problem. I will find out. Rest parameter. If I talk about the wetted parameter, that too is also simple to get, right? What should be the wetted parameter, guys? The wetted parameter for the most economical channel section, triangular channel section, will be 2 root 2y. We have all the values. Put the values in the equation and get me the answer, everybody, with full power. With full power. Hydraulic radius, y square upon 2 root y. So y to y is cancelling out. So hydraulic radius should be y by 2 root 2. Clear? You have R value, you have P value, you have area. You don't need P value anymore. You have area, you have R value. S is given to you in the questions, right? And only one thing will be unknown, that is y, because discharge is given to you as 1 meter cube per second. I'll just put all the values. So 1 meter cube per second will be equal to 1 upon n, 0.011. And this will be how much? Y upon 2 root 2 raised to the power 2 by 3. 2 by 3 under root s. S is how much? 0.0065 under root into y square. Y square is what? Area. Only one thing is unknown in this equation, and that is y. So as soon as you find this out, the answer which you are going to get will be what? Quickly tell me, guys. For your class, everyone like your video because the way you thank you so much. That's so sweet of you. Thank you so much, guys. And yep. So please now get me the answer, everybody. Rohit, Ross, Jayesh, Vatsal. Oh, already got the answer from Rohit, Vatsala. Great, 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 great. Suri, answer please. And others also. Shri Harsh. Oh, just now I have got 0.614. Brilliant. Correct answer. Others. Rashid, Nivedita, Jyoti, Aman. Answer please. Ross. Correct Nivedita. Correct Aman. Others also. Jayesh. Correct. So when you put all the values here, the value of y that you should get is 0.614 meter. Great, guys. Perfect. C is the right answer. I am third year student. I have applied for GATE. I am strong in surveying and transportation. I want to clarify marks. Is there any tip, please? You can find out this video. The title of the video is how to get 70 plus marks in GATE 2020, I suppose. So I have done this session 1 year back. That is going to help you to understand which subject have how much weightage. And anyway, in the coming days also, I will take another session how to score how much marks. That is going to help you. But yes, correct answer, everyone. This is correct answer. So brilliant, good, amazing participation. So guys, these are the staff faculty of our civil department in Gradeup. And yep, Abhinav sir, you already know him. Ankit Joshi sir is there for mathematics. Ansari sir is there for structures and for airport. Rohan sir is there for again structures, steel structures and RCC. Krishna sir is there for environment and other RCC and structure subjects jo hote hain. Anuj sir is also there for environmental engineering. I am there for fluid mechanics, environmental engineering, highway engineering. All right. So I am right now dealing with fluid mechanics here, right? And these are the superheroes of our Gradeup who have got amazing rank, and I hope that your name also appear here next year. Okay, Gradeup Gradeup green card is for those students who want to, you can say, who want to access all the test series available on the Gradeup platform. You just have to take this Gradeup card, and every test series is of your is for you. And other than if you want the live courses access, you just have to take the subscription. You don't have to pay amount for every course. So if you want it for 6 months, you have to pay 12,000 in total. 12 months is 16,800. And for 2 years, if you want, even if maybe you are in third year or second year, then you can go for this 24,000, where you will be getting all the courses for 2 years. So you have the access, right? And yes, traffic engineering, Also, yeah, if any other information is needed, just call on this number, or if you are shy enough to talk on a call, then just leave a mail on help@gradeup.co. ठीक है, मेरा काम इतना था. I just had to give you this information. Rest, it's up to you. You want to buy it, buy. You don't want to buy it, just don't buy. It is up to you. But I'll suggest, if you're preparing, then you can go for this option. You get live classes. In case you miss the live class, you can also watch the recorded form. In case you don't have good internet throughout the day, so when you have good internet, you can download the video and watch it later on without internet also. You get PDF notes after every session. You get quizzes after every session. You get all the test series, mock test, subject wise or full test. So many things are there in this. Okay. Now another thing is, from 20th November, I am coming up with the traffic engineering midnight series, that is at obviously 12 AM, but still, to be very sure, I'm telling you, all the classes in this series will be of 30 to 40 minutes, right? And I have total 6 sessions, in which 5 are theoretical plus slide questions, and the last one is completely for previous year question. This series is going to be there on Gradeup Civil Champion YouTube channel. Gradeup Civil Champion YouTube channel, so you can follow me there. And guys, if you haven't followed me on Gradeup app, you can follow me and you can ask me all the technical doubts that you have related to examination there. And in case you want to ask me anything related to your exam preparation, or maybe you are feeling demotivated, or maybe you don't have a proper plan, or you need any suggestions related to preparation, then you can text me on Instagram also. You can find me there by this name, Joshit Singh, and I'll be available there for you. My profile is public. You can see if I'm there or not. You can simply leave a text, whatever the advice or suggestion you need, you can ask me. Okay, I'll try to give you the best support and everything that you need. Okay guys, so thank you so much. I'll see you again tomorrow, same time, same energy, same enthusiasm, but different topic. But till then, you just have to do this one thing for me. Take care of yourself, take care of your family, drink water regularly, as it is very important for our health and skin, and just prep smart, stay safe, go Gradeup. Thank you so much everyone. I hope you have learned something new from this particular session, and if that happened, I'm glad. Thank you so much. I'll see you tomorrow. Till then, signing off.